All right, welcome to the garage lab. It's got all the cool stuff that we have in our classroom, but it's in my garage. First things first, I'm missing you guys terribly. Hope you're having a great day. It's weird not seeing you all the time, but this is kind of fun. We get to like try new stuff all the time. I'm pretty pumped about it. Today's goal is twofold. Goal number one is just to make sure that this works, that you can see things on your end and I can see things on my end, and that we can share communication effectively. And then goal number two is our content-wise objective for the day. By the end of this cool little video chat, you want to be able to distinguish the difference between Mendeleev's periodic table and this cool guy who we haven't talked about yet, we'll talk about in just a minute, Moseley. We want to see what his periodic table looks like, and which periodic table we're using here today, and why is one better than the other, and like what's going on in that situation. So overall, not like content-wise a super strenuous day for us, because again, the emphasis here is on making sure this technology is working. With that being said, we're going to pick up right where we left off last time I saw you, which is about a week ago, with Mendeleev. So bear with me here as we make some quick adjustments. Last time I saw you, it was a Friday. We were having the time of our lives. We were talking about how the periodic table got developed. And we were talking specifically about this cool guy, Mendeleev. He was old and Russian. He was cold. He ate lots of potatoes, and all his family was dead. And he was sitting on a train with these flashcards, and he was arranging them in order because he was an ultimate organizer. Is this ringing some bells for us? Good. That's what I'm hoping. So Mendeleev was trying to organize these elements that he had access to in a way that made sense to him, because again, he liked to organize things. And he's like, there's got to be a better way for us to remember all these elements that we have access to. And then we in class tried to make our own periodic table. We had cut out all these little cards, and we were gluing them on these colored pieces of paper, and some of us had them in like long columns, some of us had them in sideways columns, and some of us made like little triangles or like big squares. There was a huge variety in the different types of periodic tables that we were able to create with the elements that we had access to. And I think that this is a reminder for a cool point that is super necessary in order to understand where Mendeleev is coming from. And I think the biggest point here for us is this idea that Mendeleev is severely limited by the technology of his time, right? He doesn't have access to all the elements that we currently do. Here's our periodic table back here. We've got like a whole ton of elements going on. He didn't have nearly as many. He didn't have access to things like protons, or like this idea of electrons, or like all this crazy stuff. He says, these are the elements that I know about. I know some of their general characteristics, things like density and color and like state of matter, but he didn't have any access to the cool stuff that we did here today. So just keep that in the back of your mind. Don't judge Mendeleev too hard, because again, he's severely limited by the technology of his time. And I'm going to briefly pause us here, because as we move forward with regards to this idea of note taking in like a digital format, you have a couple choices. The notes for today end up being about this long. It's about maybe like half a page if you write pretty big, which I happen to have done so. And you have two choices, I think. I think choice number one is for you to just listen to this all the way through. Just like sit and be like, oh my gosh, this slideshow is so cool, and I'm having the time of my life. And then once it's over, take a look at the scanned document that I've put on Google Classroom. That's a copy of the notes, and put them into your notebook then. Option number two, I think, is to take your notes with me as we go. It's gonna require you to pause when you see that cool pencil, like is on the screen here, and then continue on. So if you're more of a start and a stopper, take your notes now. If you're more of a all the way through and then do all the notes all at once kind of person, do it that way. Whatever works best for you, we're being flexible here. But irregardless of which way you do it, you want to make sure that this title here, this Mendeleev versus Moseley, ends up in your table of contents. You got a date on it. The date you'll be doing this, oh my gosh, I don't even know what year you're doing this. It's gonna be 3/22. 3/23, that's Monday, 3/23. Make sure you got a page number, all that kind of cool stuff. So as we made our periodic tables here last week, regardless of the cool shape you made or necessarily like the structure of your periodic table, I found that when I was looking at these different tables you created, most of us tended to have arranged them in order of increasing atomic mass, meaning you had your lightest elements on one side of your table and your heaviest elements on the other side of the table, which, believe it or not, is exactly how Dmitry Mendeleev also organized his periodic table. Crazy. So Mendeleev found that when you organize your elements in order of increasing atomic mass. He found that elements with similar properties tended to be grouped together. So he found that when you started with lower atomic masses and worked your way up to higher atomic masses, everything that was like super metally tended to be grouped together. And everything that was like really brittle tended to be grouped together. And things with similar density tended to be grouped together. And he's gonna introduce this idea for us of periodic trends. Periodic may sound pretty familiar to you at this point because we've been talking about the periodic table for like a good long time. This is kind of where it's getting its name. Periodic in general means that something is happening at a regular, repeated interval. People say, how often do you go to the gym? And you're like, periodically. Meaning maybe like once a week or something, I don't know. But Mendeleev finds that these patterns of different properties, things like how metallic something is, its state of matter, how dense it is, its color, are happening periodically, which is kind of a cool thing here for us. And he's like, yes, I cracked this code. I've discovered the best way to organize these elements here together. But, he says, there are some holes in my table. He finds that when he organizes the elements that he knows about, because he's limited by the technology of his time, when he organizes them, the elements that he knows about, they don't line up perfectly. And to make them line up more perfectly, he has to basically leave some spaces in his periodic table. And because he has to leave these spaces in this table, what he can do is make some predictions about elements that have yet to be discovered, which is like kind of crazy. So Mendeleev is sitting there and he's like, man, my pattern is not perfect. Somewhere between this element that has an atomic mass of like 68 and this element that has an atomic mass of like 73, there should be another element. And he's like, we don't have an element that has an atomic mass that fits there, but I think something should be there. And what he's gonna do is actually make some predictions about specific properties of this element. He's gonna say, oh yeah, he's limited by technology at the time. He's gonna say, I think that there's something in this range, it probably has an atomic mass of about 70. He's gonna say, I think it has an atomic mass of about 5. I think it's probably a metal. I think it's probably really hard to melt it. And then what is absolutely crazy is like 20 years later, some guy comes along and discovers this element. He discovers the element that has an atomic mass of about 72. Its density is pretty darn close to what Mendeleev thought it was. It's a metal with a really, really high melting point. So Mendeleev does this a lot, actually. He predicts the existence of these elements that have yet to be discovered, not only that they exist, but their specific properties. And everyone's like, dang, Mendeleev, you're like pretty smart. Good thing you were eating all those potatoes. And Mendeleev says, yes, I know. I'm a brilliant mastermind. But there are some things that just like don't fit into my table. He's like, there are just like these weird elements that are sticking out and they're driving me nuts. And he's like, I'm just not sure why they are the way they are. And I don't have an answer for it. And it's stressing me out. He's like, but maybe it's because I'm limited by the technology of my time. Maybe it's because the atomic masses that I'm using to organize these elements aren't exact enough. And maybe if we have more exact atomic masses, these weird, like, freaky elements in my table will sort themselves out. He's like, I don't love it, but I'm satisfied with my table. And everyone says, Mendeleev, you're crushing it. You're like killing the game. Like, good work. He's like, thank you, thank you. Give me my potatoes. Again, he's limited by technology of his time. It's like our big takeaway. Like, he's limited by the technology of his time, guys. And then comes along this scary looking dude. Look at this guy. Like, can you believe him with his like creepy coat? And he's like, this guy is Henry Moseley, and he is here to basically unseat Dmitry Mendeleev. That's kind of been the moral of our story here, as we've talked about these different scientists over these past couple weeks. You're like super right until you're no longer right anymore. And this is a case where Mendeleev starts out being really, really right, and now all of a sudden isn't as right anymore. Henry Moseley is going to come along. He's a big X-ray guy. That's like what he does, is he looks at X-rays. And what he's going to do is determine that maybe atomic mass is not the best way to organize elements on the periodic table. He's going to take information that is readily available to him. He is less limited by the technology of his time, because at this point in time, Rutherford has come along and said, hey, protons are real. And Moseley's basically going to say, Rutherford, right? Remember Rutherford, gold foil experiment. There's a positive nucleus. Empty space on your atom. Okay, good, I knew you did. Moseley's going to come along and say, Rutherford, not only is there a positively charged nucleus, but there are actually like little positive things inside this nucleus, and we can count them. He's basically responsible for discovering this idea of atomic number, which is like crazy. Because if you pause for a second and very quickly look at a periodic table, which is in that big packet I gave you like 2 different periodic tables. If you look at this periodic table, I've got one right here that I'm looking at right now, we would notice that our elements are not necessarily arranged by atomic mass. They're instead arranged by increasing atomic number. So spoiler alert, Moseley is more right than Mendeleev. But it's not Mendeleev's fault, right? He was limited by the technology of his time. But Moseley comes along, says atomic number is a thing, and when you arrange these elements in order of increasing atomic number, all of your elements fit so nicely. All of those weird gaps that Mendeleev was coming across, all those like weird freaky elements that didn't necessarily make sense, are completely ironed out, and everything is perfect. And everyone's like, oh, and it's really, really nice for everybody. So Moseley's going to coin this idea of a periodic law, which basically, this is a wordy definition that I'm giving you. It says, repeating chemical and physical properties of an element change periodically with the element's atomic numbers, which is basically a fancy way of saying that when you organize elements in order of increasing atomic number, you have repeated patterns of properties, which is a little bit vague, but this is actually the foundation for everything that we're going to be talking about over the next couple of weeks. So it's easier to look at an example than to like look at this like obtuse definition. So here we have a segment, we have a period of the periodic table, a particular row. We're starting over here with potassium and moving our way, sorry, my face is in the way, all the way across the periodic table here to krypton. And what we see happening is an example of periodic law. As you start here on the left of the periodic table over towards calcium, this one's calcium, and you move your way towards germanium, but before you get there, you find that all of these elements tend to have similar properties. They tend to be really metally. They have very metallic properties, right? They're hard, they're shiny, they're good conductors, they're malleable, they're ductile, all the stuff that you typically would associate with a metal. And as you further move into higher atomic numbers, you find that you hit a period, a group, a section, where they're like kind of metally, right? They're like kind of good conductors and kind of shiny and kind of malleable. And as you move even further towards the right into these higher atomic numbers, you run across elements that are not metally at all, right? These are things like that are liquid at room temperature. They are poor conductors. They are not shiny. They're the opposite of all your super cool metals that exist here on the left. So one of these periodic trends that we're going to start to see as you organize elements in order of increasing atomic mass. Ooh, atomic number, atomic number, atomic number, atomic number. When you increase atomic number, you're going to see changes across the periodic table based on this atomic number, which is kind of a cool thing here for us. And is going to lay the foundation for what we're looking for over these next couple weeks. In fact, Friday, which I guess is the next day that I see you, we're going to discuss this specific periodic trend. This idea of how metally something is changes across the periodic table. It's kind of a cool thing here. Okay, so big takeaways for us here. Let me get out of the screen sharing mode. All right, okay. So big takeaways for us are here. Number one, Mendeleev organized the table in order of increasing atomic mass. And I like to remember it because Mendeleev is spelled with 2 E's in it, and atomic mass has 2 S's. It's like what I got, like, okay. So Mendeleev is organizing his table in order of atomic mass and can use these holes to make guesses. He's like really cool, we like him, limited by the technology of his time. Moseley comes along, says no, let's arrange it by atomic number, irons out all the weird pieces in Mendeleev's table, is the periodic table that we use here today. That's all I got. Short and sweet, to the point. If you did not take notes during this section, I think there's like 4 slides you gotta take notes on. Hop on to Google Classroom, get them in your notebook, call it a day. If you have questions, I'm in the Zoom. Come chit chat with me right now. But other than that, I think we're good to go. Next one that we're talking about here today, not today, next time that I see you, we'll talk about how we classify different elements. So we'll look at how metals are metals, how non-metals are non-metals, and then this weird like in-between group of maybe metals, maybe not metals. Pretty excited about it. Okay, that's all I got. See you soon.